Hello Shomna, I'm audible. Please just confirm whether I'm audible or not. You can write in the chat box also, yes or not. And slide is visible or not. Question number 1, week 12. Please just write in the chat box. Let us wait for another 2-3 minutes. Maybe another participant will join within few minutes. Then we'll start. Can no one join? Okay, let us start. So maybe participant will join in, video is recording. So participant will see from YouTube. So the first question is, a simple sinusoidal oscillatory wave is primarily described by option A, wavelength L and time period T, option B, wavelength L or time period T, option C, only wavelength L, option D, height and time period T. So question is asking about the simple sinusoidal oscillatory wave primarily described by. So whether you need two component, that is wavelength and time period, only option B, only means only L or only T, either wavelength or either T, or option C, only L you required, whether your height and time period required. So this is the question. So if you know the equation of your simple sinusoidal oscillatory wave, so you can very easily think about it for question number 1. Okay, let me just show you the answer for question number 1. So the answer is, here you can see, let me just take the pen. Here you can see the equation. You have to record your length as well as time period. Option A will be correct. That is capital T. Here you require, not this one. Here or not this one. The time period T. Like whatever you know, those sinusoidal wave like that, like sine wave. So for that you need to record these two things for primarily described your such kind of wave. Okay, so next question is question number 2. The amplitude of a linear water wave. The amplitude of a linear water wave is 0.5. So you have the 0.5 a value, amplitude meter. The wave height is, so you need to calculate wave height here. What will be the wave height? So very easy question. If you know about it, you can very easily give the answer. If you've gone through the your NPTEL videos, then you can very easily calculate the answer of this question. Okay, still no one joined. Okay, the amplitude of linear wave means here. So formula is your amplitude is equal to height by 2. Meaning your height is 2 times of amplitude. So here your answer will be 0.5, so 1 meter. This will be the answer, final answer for this question. But how graphically you can see these things? Let us suppose your wave is start from here. Wave is started from here like that. Like that. So this will be your amplitude A, and this is also amplitude A. But here you need to calculate the total height. So from here to here, that is maximum wave and minimum wave height, the distance between these two. So this is the your height of wave and amplitude relation. Now the next question is question number 3. A deep water. Here you have the deep water, and tan hyperbolic is given here. 2 pi d by L is equal to. So these are the very so these are the very basic questions, but you have to understand these things. Tan H, whether for deep height and for shallow height, what the values would be. So okay, so answer will be for your deep water. The tan H, tan hyperbolic 2 pi d by L will be 1. Remember, always remember. Next question. Question number 4. A deep water wavelength, a deep water wavelength for wave of period t second is equal to. Here you need to calculate these two things. The condition is given deep water. Remember, the condition is given deep water, and you have to calculate wavelength if I represent with the lambda, and wave time period is given 10 seconds. So just think within 1 minute. Okay, so let me discuss. So the formula for this your deep water wavelength, the formula will be L is equal to, or your lambda is equal to, you can say 1.56 T square. This is the formula, simple formula, and you have to put the value 1.56 into T square, that is 10 square, and here T value in your lambda will be in meter and T value in second. Okay, so whatever you will get the answer will be in meter. So 1.56 into 100, so 156 meters. So your value will be 156. Remember, that is C option will be correct for question number 4. Okay, next question is question number 5. The ratio of water depth to wavelength. Here, the ratio of water depth to wavelength greater than half for which type of water depths? Here, you have to just think on that. The question is ratio of, let me just show you the, yes, option. So, water depth. Let us suppose one channel is there and here is the water depth, this much D, and another channel and water is this much, that is a, this is deep and this is your shallow, and in between you can just think the intermediate. And your, here one thing, the wavelength you know already what is wavelength. So this value will be the one complete cycle. If you are considering from here, so up to here your wavelength will be this much, or you can say L naught or lambda also. So this value, or L you can also write. So LV and water depth is this much. So here question is the ratio of water depth, means water depth to wavelength greater than 1 by 2, that is D by L is greater than 1 by 2, means your depth will be half of the depth will be greater than half of your wavelength, that is 2. So if this much depth, so maybe here if you want to draw the wave, so your wave will be like that, that is up to here is half, but you have the more, so like that. Here also that is the same amount will be go up, so like that. So for so here if you will, no, question is not that. The question is, okay, the question is your depth will be half of the wavelength. Let us suppose wavelength value is 156 meter for the previous question. So your depth should be how much? Depth should be greater than 2 times, or greater than half, means let us divide by 2. So greater than 156 by 2, that is 78 meter. So for such type of your water bodies, this condition will be maintained, whether shallow. So first you have to understand about the, for shallow water, how, that is a definition of the shallow depth, shallow water depth. Whether it is when the depth will be greater than 2 meter, then we can say this, less than 2 meter, then we can say the shallow, or greater than 10 meter, then we can say the shallow. So you have to that quantitative definition for shallow. If you have the shallow definition, then definitely the greater than or less than, the greater than that value, your value will be the limiting value of shallow, the value will be deep. Means I am talking about, if your, let us suppose for the depth is 4 meter, less than 4 meter is considered shallow, definitely the greater than 4, the value will be deep. Okay. Or intermediate also you can think, and then after intermediate, let us suppose up to 10 meter, the value will be intermediate, and greater than 10 meter, your value will be deep. So like that you have definitions, some quantitative definitions, so please you go through for such kind of definitions. Okay, so by the way, the question is this: d by 2 should be greater, d by l should be greater than 1 by 2. So this type of condition is possible only for your deep water bodies, remember please always. Okay, next question is question number 6. Any participant join? Oh, still not any join. Okay, this is the last week of your NPTEL hydraulic engineering. So okay, so the question is question number 6. The velocity potential for a small amplitude wave is derived from Laplace equation for your irrotational flow, ideal fluid, both A and B, none of the above. Velocity potential for a small amplitude wave is derived from Laplace equation for flow, irrotational flow, ideal fluid, both A and B, none of the above. Velocity potential for a small amplitude. And what should be the value of a small amplitude? What should be the definition, quantitative definition of a small amplitude? You have to know these things. And what is the velocity potential and what is the Laplace equation? You need to understand everything. Then you can very easily give the answer. Okay. Maybe participant will join or Rajesh is joined. So Rajesh, I am audible? Hello Rajesh. You are not audible. So I am audible. You can write in the chat box also. Or screen is visible. Just please confirm. Then I'll move ahead. So maybe you will get benefit our discussion. So actually I have discussed the 5 questions. No one joined. So you have joined around 6:32. Rajesh, please just confirm you are not audible. You can write in the chat box also if your the mic is not working, so you can just write in the chat box whether I'm audible or not. Okay, so the question is this: the velocity potential for a small amplitude wave is derived from Laplace equation for irrotational flow, ideal fluid, both A and B, and none of the above. So you have to understand what is the definition of a small amplitude? Whether your amplitude value will be greater than 1, then you can say a small 1 meter, a small 1 meter, then you can say the small amplitude, or 0.5 meter, small 0, that is the your a value less than 0.5 meter, then you will say the small amplitude. So you have to understand about, you have understanding. And Laplace equation you know already. This is your Laplace equation for two-dimensional. So by using these things, so you have derived the velocity potential function for which type of flow. So just you have 1 minute. So if you know, you can write your answer in the chat box. Rajesh, you can write your answer in the chat box if you know the answer. I'll wait 1 minute. Then after I'll show you the answer. Then I'll move on the question number 7. So please. Okay, let me just show you the answer for question number 6. So here actually you can derive for both, that is your ideal fluid as well as your rotational fluid. Remember please. So option C will be correct. So some description is given here. The assumption for derive the expression for velocity potential due to propagation ocean wave are: flow is said to be rotational, ideal surface tension is neglected, and the pressure at the free surface is uniform and constant. Seabed is rigid, horizontal and impermeable. Wave height is small compared to its length, and potential flow theory is applicable. So these are the some description, the assumption behind when you will go the derive using the Laplace equation, your velocity potential derivation. So now the next question is question number 7. So a deep water salinity, here you have the salinity value. The deep water salinity for a wave of period 10 second. Wave of period 10 second is equal to. So you need to calculate here salinity. C, if I denote the salinity with C or C naught. Here you have the time period T is equal to 10 second. Then you need to calculate the salinity part. What should be the value of salinity? So actually you have to understand first the formula, the relation between your salinity as well as your time period. So if you know these things, for deep water, actually here we are talking about deep water. So very easily you can write the answer. So you have another 2-3 minutes. So please try to just write your answer in the chat box. So I'm waiting. Okay. Okay, let me just show you that. Let me just show you the answer. So before showing the answer, let me just calculate. So the relation between your salary as well as time period is 1.56 into T, meaning the value you know already. The value will be 1.56 into 10, that is 15.6 meter per second. So your 10 value in second and salary you will get meter per second. Okay. So yes, definitely your B option will be correct. Now we'll move on the next question. Question number 8. Okay. Question number 8 is, yes, the linearized form of dynamic Bernoulli's equation is. The linearized form of dynamic Bernoulli's equation is. So here you have the four equations: minus del phi by del t plus p by rho gz is equal to 0. So just for your understanding, just for your understanding, getting about the equation, phi is velocity potential, function, and your t is time definitely, and p is the your pressure, and rho definitely you know already the density, and g you know already, and z is your datum height. So this is the some basic understanding about the terminology. So option A is this, and option B is del phi by del t. I think someone joined. Okay. So I'm talking about the question number 8. So please just read and try to write your answer in the chat box. Okay, and the option B is del phi by del t p by rho z gz. Option C, del phi by del t p by rho z here and gz, and option D minus del phi by del t p by rho z plus gz. So here you have the four equations. So you have to just tell, or you have to write your answer in the chat box whether which option will be correct. The linearized form of the your Bernoulli's equation, dynamic Bernoulli's equation. So question is this. So you have another 2-3 minutes. So please you just try to write your answer in the chat box. I'm waiting. Okay, let me just show you the answer for question number 8. That is the linearized form of the dynamic Bernoulli's equation. So he okay. So here answer will be your A option, that is minus del phi by del t p by rho z gz. Remember always, please. Next, the question number 9 is deep water wavelength is, so here you need to calculate the deep water wavelength is how much times of the square of the wave period t. Here another the formula based question. So whether 1.56 times, 1.36 times, 1.86 times or 1.26 times. Which option will be correct for question number 9? So please just try to write your answer in the chat box. I am waiting. Oh, sorry, my mic was off. So here the deep, so question number 9 is the deep water wavelength is how much times of the square of the wave period t. The first option 1.56, 1.36, 1.86 and D option 1.26. This is a formula based question. So please just try to write your answer in the chat box. I'll wait 1 minute again or 2 minutes I can wait. Just please think and whatever you have learned in the your NPTEL videos, just try to write your answer in the chat box. These questions will help your final exam definitely, as well as assignments. Okay, let me just show you the answer. Let me just show you the answer. This is again formula based question. So if you know the formula, then very easily you can write. So here you can just see the L is equal to G by 2 pi into T square. So these value will constant. So G value will be 9.81 meter per second and 2 pi you know already. So when you will 9.81 divided by 2 pi, this will give you 1.56. So definitely your L naught will be 1.56 T square. So actually this formula we have discussed earlier also, one questions. Earlier means in the maybe question number 5, 6, or let me just show you. Here. Yes. The deep water wavelength for a wave period of 10 seconds is equal to, so here you can see the formula. Okay. So we are this now I think question number 10. Yes, 8 we have discussed, 9 we have also discussed. So option A will be correct definitely for question number 9. Next question is question number 10. Water particle follows. Okay, here answer is visible. So the question is asking about the water particle follow, question number 10, which elliptical, hyperbolic, circular orbit in deep water. So entire question in entire set we have discussed only about the deep water. So so generally your answer will be C, that is a circular. Water particle follow the circular orbit in deep water. Remember always some description is given here. The particle move in circular orbit in deep water with the equation is also given. So this is delta x divided by h by 2 e to the power kz plus delta z divided by h by 2 e to the power kz whole square of both this one. This is also whole square is equal to 1. So definitely this is your circular equation. So that's why I written it. That's why your answer will be correct, the circular one. Okay, next question is question number 11. Question number 11 is the dispersion relationship is the relationship between wavelength and period only, wave period and water depth only, wavelength and water depth only, none of the above. Which option will be correct for question number 11? So please just think on that and try to write your answer in the chat box. You have another 2 minutes. So please just try to write your answer. Okay, let me just show you the answer for question number 11. So dispersion relationship is the relationship between option D. Here the answer is not correct. Actually, no one, not any option correct. So here is the detailed solution is you can just see the omega is square is equal to G K T A N H K H. So I don't know how it is written and what is the way. G actually I know your meter per second square, the gravitational acceleration due to gravity, but what are the others? So actually I think here some mistake, not mistake, some explanation should be there. What is the K and what is the H? Definitely in the lecture video, sir have discussed about this term. So please you follow the lecture video and try to understand what is the term, whether KH or KT write in this format or KT. So I think this will be okay. So please just try to understand whether it is written KT like that or KT like that. So please follow the video for this actually these equations. Okay, now the question number 12. The ratio of wave height at any depth for shallow water to deep water wave height is the ratio of wave height. Remember please, the ratio of wave height at any depth for shallow water to deep water wave height is termed as, one terminology is there for this. So what should be the term? That is the refraction coefficient or diffraction coefficient. Which option will be correct? And another one, option D should be also there. Yes, and Soling coefficient. So which option will be correct for question number 12? So please just try to understand the question and then try to write your answer in the chat box. So another, you have the 2 minute, 2-3 minute. This is the last. This is the last question for this set. I have another set also. So after this question, I'll take 5 minute break and then after I'll discuss about the next set of questions. So please, I'm waiting for 2-3 minutes, then I'll show you the answer. So try to write the answer for question number 12. So please just try to write your answer please in the chat box. Okay, no one joined still. Okay, I think he has left. Okay, let me just show you the answer for question number 12. So definitely your Soling coefficient. So the ratio of wave height means h by h. The ratio of wave height at any depth, shallow water, so capital H is your denoting the shallow, to deep water depth. Wave height is termed as your Soling coefficient, that is Ks. Remember please. Very, I think such type of question you may expect in your assignment, as well as some part of questions maybe you can expect your NPTEL exam. But if you are looking from gate point of view, so I think this the wave part is not in your gate syllabus, because some student were asking in the previous actually sessions about the gate, whether it these question will help in gate or not. So definitely the previous weeks definitely will help you in the your conceptual understanding of your gate questions, about the gate questions. But definitely this is out of your syllabus of gate. So okay, from here I'll take 5 minute break, then after I'll show you the answer. Show you the answer. No, I'll just go with the another slides, or let me just share you. No, it's okay. I think just I need to switch. It should be visible. Okay, yes, new one is visible. So okay, we'll solve after 5 minutes these questions. Okay, let us start. So the your next week questions. So the linear wave theory is known as the linear wave theory is also known as Airy wave theory, Stokes first order theory, both A and B, and none of the above. For question number 12. For question number your question number 1, week 12. So please just try to, actually I think no one joined, so let me just discuss and show the answer. Okay, no one joined. So linear wave theory, here the question is talking about the linear wave theory. So yes, your option C will be correct here, both A and B. Your linear, here some detail description is given here. The linear wave theory is also known as Airy's wave theory, as well as your or Stokes first order theorem, you can also say. The first order wave theory actually. Next, next one also very easy question. Linear wave theory is only valid for the breaking wave with large amplitude, the breaking waves with small amplitude, the non-breaking waves with large amplitude, and non-breaking wave with small amplitude. So which option will be correct for question number 2? Just think. Linear wave theory, breaking wave with large amplitude, breaking wave with small amplitude. So what is amplitude? Just for your understanding, actually in the previous session I have just discussed this value A, and this is also A, just for drawing purpose, you this value is the large visible compared to this, but you just try to understand these are the same. So this is the large, whether small, but here also you need to understand the definition of large amplitude. That is quantitatively how you will define amplitude is whether large or small. You have some definition for large amplitude and a small amplitude. So definitely sir have discussed, sir were discussed in the NPTEL lectures, so you please follow the all lecture of week 12 so you can just understand the terminology part. Otherwise it is very difficult to understand whether small and or large amplitude. So yes, let me just show you the answer. So option D will be correct here, non-breaking wave with small amplitude. For question number 2, your option D will be correct, the non-breaking wave with small amplitude. Your linear wave theory is valid for this. Okay. Question number 3. Here some description is given. The linear theory is strictly speaking only, remember please, this only valid for non-breaking waves with small amplitude. Remember, the linear wave theory. Okay, here linear wave theory. The next question, question number your 4. Question number 3. Linear wave theory is based on an exact solution to Laplace equation, continuity equation, Navier-Stokes equation, and your Darcy's equation. The linear wave theory is based on exact solution to Laplace equation, continuity equation, Navier-Stokes equation, Darcy's equation. So which option should be correct for question number your 3? Linear wave theory. Anyone join? Okay, no one join. Maybe because of the today the last week or last session for this your NPTEL hydraulic engineering, so that's why I think student were not join. Okay, video is recording, so I'll upload on YouTube and a student can go through the videos, the previous year videos and this one also, week 12 video. The linear wave theory is based on exact solution. So let me just show you the answer. So we have discussed a lot about the continuity equation, Navier-Stokes equation, Darcy's equation we have not discussed, but Laplace equation we have also discussed in your previous sessions. So you have to understand, if you know then good, if you don't know then please follow the previous hydraulic engineering your NPTEL videos, as you can also follow the sessions, the question answer sessions. Okay, by the way, for the answer of this question is A, that is Laplace equation. Your linear wave theory is based on exact solution to your Laplace equation. Remember please, that is del u square by del x, that is the Laplace equation, plus del v square by del y square, del w square by del z square is equal to 0. Remember. Okay, the next question, question number 4. Dispersion relationship is the relationship between, here you need to fill in the blanks, period and water depth. Period and water depth. Dispersion relationship is the relationship between period and water depth. So here you need to fill the blank. So let me just show you the option. Free surface elevation, wave energy, wavelength, all of the above. So dispersion relationship is the relationship between whether your wavelength, period and water depth, whether wave energy, period and water depth, whether free surface elevation, period and water depth. So here you have to fill this one, then whether this will be correct statement, then you need to go with this, then you need to go with this separately, and all of the above you can just think. So which option will be correct for question number 4? Very easy question, very simple question. Okay. Let me just show you the answer for question number 4. That the answer will be wavelength. The dispersion relationship is the relationship between wavelength, period, and water depth. These three. Here the same thing is written in solution. Question number 5. The deep water conditions, the water particle path are circular, hyperbolic, parabolic, elliptic. Deep water condition, you have the condition of deep water. The water particle path, that is particle is here, then this particle follow which path, whether circular path, whether hyperbolic, whether parabolic, whether elliptical. Which option will be correct? For question number 5. Okay, let me just show you the answer. Circular one. So remember place. Next question. Deep water condition, the water particles path are circular. Question number 6. Okay. The water particle move in circular, hyperbolic, parabolic, elliptic orbit in shallow and intermediate water depth. Which option will be correct? Whether circular, hyperbolic, parabolic, and elliptic. The water particle move in which orbit? In shallow and intermediate water depth. Previously we were talking about the deep water condition, but here you have the shallow and intermediate condition. So which option will be correct? Okay, let me just show you the answer for question number 6. Yes, option will be elliptic. So previously we were talking about, let me just graphically show you. Let us first consider the deep one here. Just for graphically I will show you. Let us, this much depth is deep. Let us suppose deep. So here is the deep water here. That is, here is your deep depth. So here particle move in circular like that. But in the shallow and intermediate water depth, shallow means up to, let us suppose here, that will be shallow, and intermediate maybe up to here. You can consider the intermediate, or maybe up to here. So here actually your path follow the particle like elliptical, the water particle like that. But here is circular. So remember please. So this is the actually the graphical representation. Now we'll move on the next question. Okay. So your detailed solution is given. For shallow and intermediate depth condition, the water particle path are elliptic. Question number 7. A asymptote of function cos h kd for shallow water is kd 1, kd by 2 and kd by 3. Which option will be correct for question number 7? Just please think. Join or not? Anyone not join? Okay, let me just show you the answer. The answer will be 1. The asymptote of the function cos h, that is cos hyperbolic, for shallow water is 1. The function of cos h k t approach unity asymptotically for shallow water depth. Next question. In shallow water, the group and phase velocity are same. The group velocity is more than phase velocity. The group velocity is less than phase velocity. None of the above. Which option will be correct for question number your 8? Just please think for question number 8. So Prajapati, we were discussing about question number 8. In shallow waters, the group and phase velocity are same. The group velocity is more than phase velocity. The group velocity is less than phase velocity. None of the above. So which option will be correct for question number your 8? So you can write in the chat box your answer. Please. I'll wait 2-3 minutes. 2 minutes I'll wait. So please try to write your answer in the chat box. Okay, let me just show you the answer for question number 8. So the group and phase velocity are same. For shallow waters, your group and phase velocities are same. Remember please. In shallow water, the group and phase velocity are same. Here it just description is written. Question number 9. The shallow water depths group salinity is a function of wavelength only, water depth only, both wavelength and water depth, none of the above. For shallow water depth, the group salinity is a function of wavelength only, the water depth only, both wavelength and water depth. Option D, none of the above. Which option will be correct for question number 9? So please just think on that and try to write your answer in the chat box. You have another 2-3 minutes. Okay, for previous question you were telling about option B, that is group velocity is more than phase velocity. Not option A was correct. The group and phase velocity are same. Okay, good. So please for question number 9 you can also write your answer in the chat box. Okay, let me just show you. The option B will be correct for question number 9, the water depth only. So here the description is, in shallow waters, the group and phase velocity are same and are the function of depth of water. Only depth of water. Remember please for question number 9. Now we'll move on the question number 10. The deep waters, in deep waters, the group celerity is a function of wave length only, water depth only, both wavelength and water depth, none of the above. The previous question was about the shallow water depth. The question number 10 is the deep water depth. The group celerity is a function of which option will be correct for question number 10. So please you can write your answer in the chat box. You have 2-3 minutes, next 2-3 minutes. So please just try to write your answer for question number your 10. So after that another set I have for your solution. That is for your another question answers. Because we have time, so let us discuss more question today. Okay, let me just show you the answer for question number 10. Wavelength only. Here remember please, in the previous was water depth only. That is for shallow water depth. The group salinity is a function of water depth and only water depth. And for deep, your group salinity is a function of wavelength only. Remember please. For question number 11. While deriving the expression for velocity potential using small amplitude wave theory, the flow is assumed to be irrotational. Option A, option B, rotational, compressible, all of the above. Which option will be correct? Please just recall your understanding about your this topic from your NPTEL videos and try to write your answer in the chat box for question number 11. Please everyone. For question number 11, please everyone try to solve the question. Write your answer in the chat box. Anyone please, you can write your answer in the chat box. Anyone can write. Okay, let me just show you the answer for question number 11. So the answer will be Irrotational. The assumption should be irrotational. Remember, please, always. Next question. Here some solution, detailed solution. The flow is assumed to be irrotational in a small amplitude wave theory. The next question is, in linear wave theory, the governing equation for velocity potential function is solved analytically using integral transform technique. Option B. Here, oh, here is answer is visible. Okay. So conformal mapping, method of separation of variables, none of the above. Which option will be correct for question number 12? So definitely C option is visible. So C will be correct, method of separation of variables. So remember please, method of separation of variable is used to obtain solution of Laplace equation for velocity potential function, method of variable separation. Okay. This one. Okay. So let me just show you. Here is the another set of questions. So what is the primary assumption? What is the primary assumption underlying linear wave theory? So whether waves are non-linear, wave amplitudes are small compared to the depth of fluid, wave propagate in small speed, wave propagate at the same speed regardless of depth, wave energy is constant along the wave profile. So what is the primary assumption underlying linear wave theory? So please just think on that. So let me just discuss what is your amplitude and all. So wavelength you know already from here to here. This the complete one cycle is wavelength, and amplitude from this one from mid to height crest, and from lower crest also, and direction of travel here you can see. And these point, the above point from 0, we know the crest, and the lower one is top. So okay, by the way, the question is about the what is the primary assumption underlying the linear wave theory. So anyone can write the answer in the chat box. Anyone please? Okay, let me just show you the answer. The answer will be wave amplitude are small compared to the depth of fluid. Okay. So here the explanation is linear wave theory assume that the wave amplitude are small relative to the depth of fluid, and this assumption allow the application of linearized equation of motion and simplifying the analysis of wave behavior. The next question is, which equation governs the behavior of velocity potential in linear wave theory? Euler, Bernoulli's, Laplace, Navier-Stokes equation. Which equations? We have discussed I think 2-3 times in the previous set of questions today. So just please try to write your answer. Which equation governs the behavior of velocity potential in linear wave theory? Euler, Bernoulli's, Laplace and Navier-Stokes equation. So anyone please just try to write your answer in the chat box for question number, that is for this question. Yeah, question number is not written. So anyone please can write. Another one minute I'll give you. So within 1 minute, just please try to think and try to write your answer for question number, for this question, what is visible. Okay. 1C you are telling. Ranjit is telling 1C Laplace equation. Yes, definitely. Yes, option C will be correct for this question. So yes, you are correct. Now we'll move on the next question. In linear wave theory, explanation is given here. The velocity potential is governed by Laplace equation which describe the distribution of wave potential throughout the fluid domain subjected to appropriate boundary conditions. Next one, what does the dispersion relationship describe in wave theory? The relation between wave frequency and wave amplitude, the relationship between wave energy and wave height, the relationship between wave speed, frequency and wavelength, and the relationship between wave depth and wave celerity. For this question, just please try to write your answer. Which option will be correct? So anyone please just think on that and try to write. Okay, Ranjit is telling for B. Not here the question number is not written, so you can write your answer only. B you are telling the relationship between the wave energy and wave height. Okay. So let me just show you the answer. Option C will be correct. The relationship between wave speed, frequency and wavelength. Remember please the dispersion relationship describe how the speed, frequency and wavelength of waves are related. In it characterize how wave properties vary with each other, particularly in context of linear wave theory. Okay, the next question is what is celerity in context of wave? Rate of change of wave amplitude, speed at which wave crest propagate, the ratio of wave height to wavelength, the depth of water at which wave breaks. What is the celerity in the context of wave? So please just anyone can write the answer. Okay, Ranjit is telling 3A, the rate of change of wave amplitude. Okay, let me just show you answer. Option B will be correct actually. Remember please, the speed at which wave crest propagate. What is wave crest? So I think I have just shown you what is wave crest. So these are the wave crest. How it propagate. That is the topmost part of your wave. Okay. So the next one, celerity refer to the speed at which wave crest propagate through a medium, and it represents the velocity of energy transport associated with the wave motion. So this explanation. Which factor primarily influence, the next question is, the which factor primarily influence local fluid velocities and acceleration in wave motion? Which factor primarily influence the local fluid velocity and acceleration in wave? Wave frequency, water depth, wave amplitude, and water wave direction. Which option will be correct for this question? Anyone can please think and write the answer in the chat box. Okay, let me just show you the answer. So here wave frequency. The wave frequency primarily influence the location, the local fluid velocity and acceleration. Remember always. Next question. So the primary factor influencing local fluid velocity and acceleration in wave motion is wave frequency, and higher frequency result in the greater oscillation and therefore higher local velocities and acceleration. Next question is, what does the group celerity represent in the wave theory? Group celerity we are talking about here. Speed of individual wave crest, speed at which wave packet propagates, speed of wave troughs, and speed of wave energy dissipation. So which option will be correct for question number, for this question actually? Here numbering is not given. So anyone can please write the answer for this question. For the previous question, the answer was, let me just, A was correct, that is the wave frequency. For this question, anyone can write the answer. What does group celerity represent in the wave theory? Okay, 5C. That is, you are telling about the C, speed of wave troughs. Here we are talking about group celerity, not only the celerity. Okay. So let me just show you the answer. Speed at which the wave packet propagate. Remember, please, we are talking about the group. So definitely packet means the number of the group of particle. The group celerity represents the speed at which the wave packets consisting of multiple wave in different frequencies. Oh, here is the consist of multiple waves of different frequencies and wavelength propagate through a medium. So group celerity means the lot of wave you have with different frequencies and wavelength propagate through a medium, and it describe overall movement of the wave. Okay. So at which point is the pressure under progressive wave maximum? At which point is the pressure under progressive waves maximum? Wave crest, wave troughs, halfway between crest and troughs, bottom of the ocean. Which option will be correct? Question is, at which point is the pressure under progressive wave maximum? Pressure, we are talking about the pressure, maximum pressure. Wave crest, wave troughs, halfway between crest and troughs, bottom of the ocean. 6b. You are telling that is the wave trips. Okay. Here what is trips and crest given. So yes, wave, your pressure will be higher at the wave crest. The pressure under progressive wave, we are talking about wave. So pressure under progressive wave is maximum at wave crest, and this is because the water particle are displaced upward at the crest, resulting in increased pressure due to the weight of water above. Weight of the water above. So remember please the explanation. Next question. What is the relationship between wave energy and wave height? Linear, quadratic, exponential and inverse. The relationship between wave energy and wave height. So please just try to write your answer for question number this. Anyone can write. Okay, 7c you are telling. That is exponential. Okay, let me just show you. So here I have some relationship. So here you can just see E is equal to 1 by 8 rho gh square, and E is equal to this one. So definitely the square means quadratic. So if that is the relationship is quadratic, not exponential. So I'll share this one. You can go through the this slide. That is the question answer. Now we'll move on the next question. Here the explanation is given. The relationship between wave energy and wave height is quadratic. Wave energy is proportional to a square of the wave amplitude, wave height, that is the wave amplitude means, and indicate that the energy increase significantly with increase in wave height. What determine the phase speed of wave? What determine the phase speed of a wave? Wave amplitude, wave frequency, water depth and wave wavelength. So anyone can write the answer for this question. The wave determine the phase speed of a wave. So just anyone can write. Generally in civil engineering at undergraduate level, we will discuss less about it, the wave concepts in fluid mechanics. But to have the advantage in NPTEL, you have this wave one, the one dedicated week for wave theory, so you can get advantage for this. You go through the videos and try to understand if you want to explore these things. Okay, for this question anyone can write the answer. What determine a phase speed of a wave? Okay, so let me just show you. That is the wavelength. Remember please, wavelength. The phase speed of wave is determined by the wavelength of wave, and it represents the speed at which individual wave crest propagate and is inversely proportional to the wavelength. So remember. And how is wave frequency related to wave dispersion? How is wave frequency related to the wave dispersion? Higher frequency leads to lower dispersion. Lower frequency leads to lower dispersion. Higher frequency leads to higher dispersion. And frequency does not affect the dispersion. Which option will be correct for this question? Anyone can write? How wave frequency related to wave dispersion? Anyone can please? I'll wait 1 minute more. Okay. So the answer is, that is C, the higher frequency lead to higher dispersion. Remember please. Higher frequency leads to higher dispersion. Wave dispersion refers to the phenomena where wave is different frequencies travel at different speed, and higher frequency wave greater experiences greater dispersion, leading to a more significant separation of wave components. The next question is, what term describes the speed at which wave envelope of a wave group propagates? The wave phase speed, group celerity, wave frequency, and wavelength. Which option will be correct? So anyone can write, because we have the time less and we have the lot of question I have, so I want to just go through the each questions. Okay, let me just show you. The group celerity. Remember please, the term describes the speed at which the envelope of wave group propagate, known as the wave celerity. Envelope means lot of wave. The group celerity represents the speed at which the envelope of wave group propagates through a medium, and it describes the movement of overall wave packet formed by the superposition of individual wave. Next question is, which equation governs the conservation of mass in fluid? Bernoulli's equation, Euler equation, Laplace equation, and continuity equation. Everyone know. I have discussed a lot about it. Definitely the continuity equation will be correct for question number, this question actually number is not given here. Next question, what term describe the time rate of change of wave height? Time rate of change of wave height, remember please, time rate of change of wave height, which term describe? Wave amplitude, wave frequency, steepness, and the wave slope. Which option will be correct? Anyone can write within 1 minute. If anyone want to write, please just write. B option you are telling, wave frequency. Okay. Wave steepness, remember please, always option C will be correct. The wave steepness refers to the ratio of wave height to wavelength, describe the degree of slope stiffness of the wave profile. The next question is, in which direction do water particle move in a progressive surface wave as it pass? Circular motion, linear motion, up and down motion, and the stationary motion. So, in which direction do water particle move in progressive surface wave when it pass? So, definitely in circular motion. Always remember, water particle in a progressive surface wave move in circular motion as wave pass through them, and this motion becomes smaller with depth and negligible below the wave base. And which factor primarily determine the wavelength of a wave in deep water? Wave amplitude, wave depth, wave frequency, and wave celerity. Which factor primarily determine the wavelength of wave in deep water? So anyone can write. Okay, B you are telling. Okay. For this question you are telling B or not? Okay, B you are telling. Okay. Wave frequency, that is wave depth. Here you need to understand the which factor primarily determine the wavelength of deep wave. So in deep you are talk about the depth, water depth. The deep water, here we are not talking about the, not, you are telling the water depth, but answer will be the Wave frequency. Remember please. Answer will be wave frequency. So which factor primarily determine the wavelength of wave in deep water? That is your wave frequency. In deep water, wavelength of wave is primarily determined by its frequency, and it is inversely proportional to the frequency, meaning higher frequency wave have shorter wavelength. Next question. What term describes the maximum vertical displacement of water surface from its undistributed positions? Wave frequency, wave height, wave amplitude, wave period. What term describes the maximum vertical displacement? So wave amplitude, definitely wave amplitude will be, we are talking about here the vertical displacement. So you know the amplitude will be correct. The wave amplitude represents the maximum vertical displacement of a wave surface from its undisturbed positions, and it is a measure of wave's intensity. Next question. What phenomena occurs when the wave approach a coast and bend due to change in water depth? Wave diffraction, and the wave transmission. When the What phenomena occur when the wave approach a coast? You have might seen the coastal lines and bend. That is a bend also, we are talking about bend due to the change in water depth. So maybe your answer will be A, that is the wave refraction. This phenomena we know the wave refraction. The wave refraction phenomena occur. Wave refraction is the bending wave as the wave approach the coast due to change in water depth, and this phenomena is caused by the variation in speed caused by the changing depth. Next question. Which term describe the time it take for one full wave cycle to pass a fixed point? Wave amplitude, wave frequency, wave period, and wave velocity. Which term describe the time it take for one full wave cycle to pass a fixed point? This question is the last question for today, so please anyone can write. C, you are telling wave period. Yes. So let me just show you. Yes, wave period will be correct. So that's all for today. So we'll discuss. Okay, this is the last week for your NPTEL hydraulic engineering. So 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 thank you all for your participation, and best of luck your final exam. So thank you everyone. So I'll share all the slides. Actually we have solved a lot of question today. So I'll share in the that is a file whatever I have provided in the Google Drive. So thank you all. So now you can leave the class. Now please everyone can leave.